When you're dealing with something as complex as building a rocket or as building a launch pad, being extremely mindful of the critical path is important. And what the critical path is the longest set of sequential events that are gated by each other that must be completed in order for a task to happen.
Attention all operators on LVN0. We're getting ready for a pre-op brief for Flight 12 here. We're going to start off with some comm protocol. T-minus 1 minute.
When we see an unexpected response, how confident are we in being able to explain that, such that we're not unknowingly walking into an actual bigger problem that this was just a small symptom of?
Holding at T-minus 40 seconds.
Yes, sir, got you.
This looks like a blip on blind pressure when we unpinned. Pressures and preloads are healthy.
Copy that. And what is the time we would unpin at? Okay, copy, agree. We should attempt again.
On LVN0, ship QDZ actuator blind outside QD vent pressure range.
On anomaly 0, tower curry, I think I'm going to recommend actually stand by. It's drifting back into range.
Is it going to fire again, tower mech?
Possibly. It seems like it's part of the dynamics.
There's the pinner that keeps QD line from the whole QD element and it swings back. There's a pin that locks it into place. The hydraulic actuator is not pulling it up. It seems to be.
And Elon is actually really, really good at quickly absorbing information, understanding the stakes, understanding the consequences, understanding if today's our day or not. Yeah, it's hard to tell because this is all fogged up from cryo, but it's essentially right there.
Tower styro, are you on anomaly 0?
Yes, sir, got you.
I don't have an explanation for why it did not unpin the second time.
I personally have never felt any pressure from Elon of like, it doesn't matter, hell or high water, we're flying this rocket. Like, absolutely not. That's not his style. And like I said, critical path to Mars is not blowing up rockets. Guys, I recommend we release hold and give it one more chance to unlatch with where we're at.
Ship XYs are not going to close out and damped, but I believe that's okay.
Okay, we have just enough time on the vehicle to attempt one more time, so I recommend we clear the hold, let it try to unlatch it at the 100 bar we're at.
We're still stuck in dampening though.
Understood, we'd be reattempting with the same hydraulic pressure. Cool, this will be our last attempt and then we're done on the rockets.
When we're only a week out from flight, my main focus is getting into flight. The thing that separates us from a lot of other companies is that we test fast and we test often, and that includes launches. We want to make sure the vehicle's all ready to go. We want to make sure the ground's all ready to go, but we also don't want to be caught in analysis paralysis.
Our main objective today is a 10-engine static fire. Aboard. On LVN1, looks like we kicked out 2 combustors from the apex bank being pelted.
There was a pad side abort called. These things were holding like 5,000–6,000 tons of propellant plus the rocket weight. And it's like, okay, well, why didn't you guys simulate that? It's like, well, because we didn't have anything that weighed that much. Like, this is the first time we put anything on it that weighed that much. So there's just so much that you have to think about and then be very paranoid on.
We kicked out early. All teams triage alerts, prepare for offload.
We actually had another pad abort on the diverter.
Basically, right during engine firing, it was so much noise and vibration that it actually shook the sensors that are located out in this area enough that they were aborted us out of the test. We went back, obviously, afterwards and looked at all the data and tried to come up with smarter ways to basically still protect the integrity of the diverter throughout the operation while changing our parameters so that we were making sure that we would not abort again.
A flame diverter is like a super simple concept that is like not at all complicated in operation and is just absolutely murderous in the details. These are extremely sophisticated thermal load sensing devices. If they turn into melted metal slag, then you know that you got too much heat. If you melt this, you're hotter than aluminum melts. If you melt this, you're hotter than zinc melts. If you melt this, you're hotter than copper melts. If you melt this, you're hotter than Sharpie melts. So we're sub-Sharpie. We have all of this mass flow, all of this energy that is just absolutely trying to obliterate our pad. We want to give it a thing to obliterate to keep from obliterating the things that we care about. And the thing we give it is water. The amount of energy that water can absorb is like miraculous. And so if you can get high enough pressure water in the right places and just allow it to flash boil that water, then it solves a lot of the problems for you. Like the idea is that the steel never gets that hot. The structures never get that hot because the water absorbs all that energy, turns to steam, and everything's okay.
So for this flame deflector on pad 2, we're sitting somewhere in the neighborhood of about 650,000 gallons per minute. That's approximately in the range of about like 1 entire Olympic swimming pool being drained in the course of a minute.
You're trying to look into this thing and you see how glowing hot it is. It's just a pretty impossible environment to keep something happy in. And you zoom in and the flame deflector's still there. So that's the reason we build those things.
Putting the rocket into human terms is something really tough. 65,000 pounds per second of propellant that is coming out of the engines. And again, just like 18 million pounds of thrust, like what does that number mean? I think of like 11 Ford F-150 trucks per second. just zipping out of the bottom of the rocket. It's like, imagine if you had the world's biggest machine gun, except for instead of shooting bullets, it was shooting pickup trucks, and it's just firing 11 pickup trucks per second out of the bottom of the rocket. It's like, do you think your stuff could survive that?
For the last, week or two, it's mostly just been running on stress and caffeine because we had so many things that we were trying to incorporate, and there's just a lot riding on this test. The previous test that we did not achieve enough duration such that we had the engineering data that we needed to be confident moving into flight. If not able to get this test off successfully today, then we're pushing launch day for day, which is an extremely big drag on the entire program and all the engineering teams involved. So there's always pressure going into an op, but this one day is particularly high.
This was a big day, the 4th attempt that we've had for a static fire, and we finally went full duration on all engines, so feels really good. I'm super relieved. Again, it was like pretty dynamic, and having done this 4 times now, it's like, man, what else can go wrong here? Because we just haven't seen the vibration and the temperatures that we're about to be subjected to.
We've never connected the QD to a vehicle, and we've never flowed propellant into a Starship on pad 2. So although this was a really big milestone, the next step is to prove that those systems work in the way that we designed them to.